We're going to be looking at a related rates problem that involves an angle of elevation. We are told that a rocket is launched vertically upward from the ground. I have a little picture drawn down here so that you can see what that looks like. And it is rising at a rate of 40 meters per second. There is an observer that is standing 60 meters away from the launch pad. We need to find at what rate is the angle of elevation from the observer to the rocket increasing when the rocket is 80 meters above the ground. What we're going to do now is we are going to put in some variables in our diagram, and then we're going to fill in what we're given, what we need to find, and then the equation that relates what we're given to what we want to find. I'm going to mark that this point here is our observer. We are assuming that the observer's eyes are at ground level, so the vertical distance to the rocket is just the height above the ground. If the observer's height were included, we'd adjust the vertical side of the triangle by adding that height. Let's let the distance from the rocket to the ground be equal to y. And then this is our angle of elevation, and we're going to let that be equal to theta. The other piece of information that we need to put in our diagram is that the observer is 60 meters away from the launch pad. Here's the launch pad, so we're going to put this distance is 60 meters. Now let's see what else we're given. We are told that the rocket is rising at a rate of 40 meters per second. So the rate of change of the rocket is dy dt, and that is equal to 40 meters per second. We want to find at what rate the angle of elevation is increasing, so that is dtheta dt, when the rocket is 80 meters above the ground, so that is when y is equal to 80 meters. Now what we have to do is we have to find an equation that relates y and theta. So here's y and here's theta. And then we don't know anything about the hypotenuse, so we're also going to have to use this distance of 60 meters. The trig equation that's going to relate these three variables is going to be tangent of theta is equal to y over 60. Now what we're going to do is we're going to take that equation and we are going to differentiate it with respect to time. So let me go ahead and write our equation down here. Tangent theta is y over 60. And we're going to take the derivative with respect to time of both sides. So the ddt of tangent theta is ddt of y over 60. The derivative of tangent is secant squared theta times dtheta dt, because it's a function of time. And then we have a 1 over 60 that we can pull out on the right-hand side, and then we have a dy dt. We want to find dtheta dt, so let's go ahead and let's solve for that. We have dtheta dt is equal to, let's put the dy dt up here on top, and then in our denominator we have 60 secant squared theta. To make this easier, let's use the fact that 1 over secant is equal to cosine, so we can write this as cosine squared theta times dy dt, all divided by 60. And I'm going to go ahead and put that our 60 is in terms of meters. Now we want to find dtheta dt when y is 80 meters. Notice in our equation that we have cosine squared theta. So I'm going to put down here that we have to find theta when y is 80 meters. I feel like this is the part that students always get confused with. Let's go ahead and let's draw our diagram again. we had a triangle. Here was our theta. This distance here was 60, and now we're told that this distance is 80. And we need to find cosine theta. So I'm going to let our hypotenuse be equal to z, and we can say that cosine theta is adjacent divided by hypotenuse, so that is 60 over z. And now we need to know what z is. I think this is why it's confusing, because you have to find so many things. Z is going to be the square root of 60 squared plus 80 squared. So let's see, this is the square root of 3,600 plus 6,400, which is the square root of 10,000. So that's at least nice. That is equal to 100. So we can say that cosine theta is 60 over 100, which is 6 over 10, and then dividing both by 2, we get 3 over 5. So let me go ahead and highlight this. Cosine theta is 3 over 5. Now we're going to take this and go ahead and plug it back in. Let me draw an arrow here so you can see where I am. We're going right up here. So cosine squared theta is going to be 3 over 5 quantity squared. We need dy dt. Let's go back up. That is 40 meters per second. And then we divide this by 60 meters. So we have 9 over 25 times 4 over 6. Now, here is something super important. We have to think about units. Because theta is an angle, the rate of change of our angle is going to have units of radians per second. Because the meters here canceled out. Now let's see, we can go ahead and simplify this. We have 36 divided by 6, which is just 6. So we get an answer of 6 divided by 25 radians per second. This tells us that the rate of change of elevation from the observer to the rocket is increasing at a rate of 6 over 25 radians per second.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.